Hello everyone, this is Prashant here from Magna Infotech Carrier Services. So this webinar has been hosted by Magna Infotech Carrier Services, and it's a learning platform which aims to bridge the gap between one expertise and growing industry expectations. So the prime objective is to provide IT skills, individuals training to align them to skill set that is most suited to the organization today, while also preparing them for the future strengths as well. So this webinar provides a brief overview of data science and the study of when informations come from, what is the representative, and how it can be tuned into a valuable resource in the creation of business and IT strategies. The number of new data science and analyst jobs advertised per month increased by 70% between April 2017 to 2018. Job roles such as business analyst, data analyst, and analyst engineers is high demand across the leading companies. So before starting our session, it's our pleasure to introduce our trainer, Rishikesh. So he has almost 8 years of experience in the IT industries. So it's better that he will be giving us a brief introduction and take the session ahead. So Rishikesh, over to you. Please take the session overhead and take it over you.
Thank you very much, Prashant, for the warm introduction. So hello everyone. So this is Rishikesh here. So I'll be the guide for you today to get you through the interesting journey of what is data analytics, what is data science, and the different perspectives to this thing. So a short brief about me. I work as a senior data scientist in Mumbai with one of the company Morningstar, which is an equity research company, and I have been doing the training for past 2 years with the various vendors for data science, data analytics, Python, machine learning, deep learning, artificial intelligence, so for the different types of topics. In all, I have 8 years of experience in the IT industry. Prior to joining the data science, I was into the testing domain. So I used to do performance testing. And from the testing, I worked for testing in close to like 4 years, and then I started my journey toward the data science. I was able to make a shift, and now I'm working as a data scientist doing the training. So I do provide classroom training, online, the corporate training for various companies. So that's just a brief about me. So what we try to do in Morningstar is we try to automate many of the stuff related to the data collection, like how the unstructured data which we have in the text. In equity, we have lot of data which is mostly unstructured in nature, and using the machine learning allows us to convert them to structure, and after converting them to structure, we try to get some information which requires a manual effort from lot of people. Like people have to manually sit, open the documents, read through the content, and collect the data. But we do this data analysis, data science, machine learning to automate the stuff, so people don't have to do that manual stuff, and their work can be automated. Okay, so now let's start further for our course to understand what is this Python and why are we using this, why is it so popular, why everyone is speaking so much about Python nowadays. You guys may have this question. So Python, one of the biggest reasons that Python is now being used is it can be used by people who are from the technology, people who are not from the technology. The ease of use is very good. So the learning curve that you have with the Python is much faster as compared to Java, C, C++, PHP, and the different languages which we had in the which we have still. But Python makes it a lot easier for people to get started with the programming. So that's the biggest advantage. And the one other reason it is called as an interpreted language. So this interpreted basically means we don't have to compile it like what used to happen in the previous program. So we write a code, and then after writing the whole code, you save it, you compile it, and then only you are able to run the code. But with Python, we don't have to compile before running. We can start running the code one by one there itself. That is one beauty of the data analysis, because we can do one by one the data analysis there itself. So interpreted is the biggest advantage. Object oriented is one of the ways by which we can represent a real world entities into the programming. Like, what do I mean by real world entities? If I have to represent a person, now person can have some different attributes. So he can have a hands, he can have eyes, he can have legs. So you will have a different types of attributes, and with every person there will be some set of actions. Actions like he can walk, he can see, he can talk. So there are different actions. So if we want to represent certain kind of an entity like this into the programming language, we have this object oriented. So this helps us a lot to define the real world entity into the program. For example, in a banking, so banking account may have a lot of details like what is the account number, who's the customer, what type of account is it, and what all actions we can do with the account. We can do withdraw, we can do deposit, we can do the fund transfer. There are different actions. So all this object representation is a very good feature which is there with the different programming languages. Python has both of the world. So there is a object oriented and there is a procedure oriented, where you don't define objects. So there are certain languages which only allows to be used with only objects. So Java is one of the language which doesn't allow you to do anything other than object. You have to define everything into the object. Python gives you both of the world, where you define the things without object or you define the things with the object. The high level programming language basically refers to as how this language allows people to work with the machine without having to deal with the insights of how it is doing the task. As we all know, all the machines, all the computers work with the binary 1-0 language. So that 1-0 language is something that we humans cannot encode. So this high level languages allows us to define a code in a very human friendly way, and when we run them, those things get converted to this machine level language for the execution. So Python provides us this high level language which makes it very much easier for us to do it as we are trying to define it in our own English language. So that is the beauty of it, with a dynamic semantics that we will understand a bit later. So Python was created by Guru Rusum in 1989. So he's a very well known figure in Python. He has been into the Python improvement for a long time. Now recently he has been retired into it, but he has contributed a lot to the development of Python. The last one thing is it is easy to learn. So I have in the previous trainings I have trained people on Python with technical background, without technical background, and everyone was able to understand and implement things with that. So that is a beauty. If we do with the Java, C++ language, for the people who don't know programming, for them it becomes very difficult. So guys, before continuing further, I would like to say that if you have any questions in between, please post them. I would be looking in them in between to answer them. So if you find any questions, if you have any questions, just put it on a chat window, and after, I'll not be able to immediately respond, but I'll cover certain topic, and at the end of certain topics I'll look at the questions to answer it. Okay, so what is this data analysis all about? So let's take this as an example. We have a good amount of data for unemployed youth across the globe. So this data is ranging from 2010 to 2014. You can imagine this is a big data for every country, for every year. So we have this big data, and now from this big data, if we want to ask certain questions like what would be the percentage increase in the unemployed youth in Afghanistan. So I'm interested in a specific country, and I'm also interested with the specific year 2010 to 2011, and even I want to convert this number to the percentage. So here we are trying to answer some questions, but it requires a lot of changes in the data. It requires a lot of filtering in the data. So this is what the analysis is, where through the data we want to answer some questions. We have a questions and we want to see what is the answer for those questions from looking at the data. So let me see if you guys have any questions till now before we go on. Okay, I hope everyone is able to see the screen. If not, please let us know. Yeah, and any questions, please drop them at any time, guys. So now about the visualization. Why we do this visualization? Visualization helps us when we have like a very huge data. It is very difficult to look at the data which is very huge. You cannot go through every single number, every single value which is there. Let's imagine we have 1 million rows. From this 1 million rows, if the unemployment rate for every country, let's imagine that we have a huge number of rows. We cannot go through every single row to understand what that data represents. It is very difficult. To do the visualization helps us quickly get the overall picture of the data in a single graph. There are various types of graphs. There is a scatter plot, there is a histogram, there is a line chart. So we have various types of graphs available which we use to analyze the data. There are the bivariate analysis, univariate analysis. There are different types of analysis which helps us to go through the data and understand what is there in the data. So it gives us a very good pictorial and a graphical format to look at the data in a single view. Rather than going through the whole data, which may take even hours, looking at the picture talks a whole picture into the single view. That is the benefit of it. So in visualization, we try to analyze the data, we try to transform certain data which is there, because some data cannot be visualized directly. The unstructured data like text, video, all those things cannot be visualized directly. So we need to transform the data to some structured form so that we'll be able to visualize them. Documents inside, where we want to like find out what is present in the document, who's talking with whom, what are the entities being represented. If we talk about like the sentiment analysis or a customer reviews, when people keep on posting on the Twitter, many companies use that posting from the Twitter to understand what people are talking. For example, they want to identify whether people are talking positively about the branding or whether they are talking about negatively about the branding. So this kind of document insights, the transformation analysis, we try to analyze this whole data through the visualization. So this all are insights into the data. We are trying to find out some important and interesting behavior out of this given data. So who is using the Python currently in the industry? So Python, you may think, okay, are really people going to use the Python? Is it that good? Who all are using it? So in this, you will see a very big names. To start with, YouTube is primarily built into Python. They initially started with like PHP, but later on, like in 3 to 4 months, they started completely migrating into Python. So majority of their code base right now is into Python. Why? Because it is a bit easier and it allows a very fast prototyping to see and create new things. Google. So the inventor or the founder of the Python used to work with Google in he has worked with Google for around close to 8 to 9 years for a time. So he has extensively used Python there. And recently, the developer was with the Dropbox. So he has also worked here for close to 6 years. And last year only he has exited from the Dropbox and he is not with Dropbox right now. So he has also worked with Dropbox extensively. The Dropbox is like a content sharing service and it uses Python extensively. If anyone knows about IoT, the Internet of Things, Raspberry Pi is one of the very basic tool which people use for developing the things. Anyone heard about the Raspberry Pi? Just say yes or no in the chat if possible. Okay, I see few people are saying yes and many people say no. So it's a very interesting tool that I would say you can look, because earlier dealing with the electronic devices was very difficult for normal people. Even electronics engineers, they have a lot of difficulty to build this electronic devices. But with the Raspberry Pi, the things have improved a lot. The majority of the things comes into the plugins and you just have to use them. It's like a credit card shaped devices which are used to like measure the temperature in the room, fit a small camera into it, or you can use it into some remote devices to operate them. It works with the Wi-Fi and has a very interesting features. So I would say have a look at it. So Raspberry Pi tutorials all comes with the Python. So all of the educational material for the Raspberry Pi is built into Python because it's much faster. So people can immediately get started with using the Raspberry Pi. Many of you may know about the torrent. So BitTorrent is one of the peer-to-peer file sharing system. For this also the majority of the code base is built into the Python. NASA, everyone knows about it. So NASA is also using the Python for, if you see this word, it says scientific programming tasks. Python has a lot of modules. So modules are like some additional features which are created by different people. So these modules are available where you can do all the mathematics. You can do Fourier transform, you can do statistics, you can do derivatives, integration, optimization. There are a lot of different scientific methods available in Python. You don't have to like do a whole derivation, just a single liner function for all the things, which makes it much faster for doing the scientific programming stuff. So as this has a lot of scientific features, the NSA also uses it for cryptography and the intelligence analysis system. So this, as I said, like a cryptography and intelligence also works with the mathematical part. So this mathematical availability here allows it for cryptography and intelligence. So Netflix also uses this for certain tasks, not the whole thing, but it uses it for certain small things, for a quick and important things. So Netflix also uses it, and many of the machine learning and all applications and all the systems is majorly developed with the Python. Sorry. So those are just a few companies that we are right now seeing here, but every company right now which is there in the market will have application of Python, one or other. There will be some or other application you will see that every company is focusing on. So Python is very useful to learn. Okay, so let's learn like why it is so popular. So few things that we already discussed. It is easy. It is very simple and easy to learn. It has a lot of flexibility. The code base is like not that complex as the other languages. You will see many single functions for doing different activities, different one liner of code to do a different activity. The other major benefit is it is completely open source. Anyone can use it. Anyone can create their applications, deploy it without any restrictions. You will like have a full freedom to use it, modify it and reuse it the way you want it. It is a high level language. It allows us to convert a human readable code into the form of a machine readable form. We cannot as a humans develop this machine readable form. It may take us a lot of time to develop those kind of machine readable forms. So that's why we have this high level languages which helps us to develop the things in a human language and which we can transform, compile back into the machine readable form. So that's the biggest advantage which we have as compared to the 20-30 years back programming languages. So Python allows us this flexibility as to create the code in a very human readable form. Portable, you can run Python in Linux, Windows, Mac, different types of Linux systems like Solaris, AIX and different PlayStations, Raspberry Pi. There are a whole lot of devices which will allow Python to be run. Even in Android, you will have a Python executable thing. You can run Python even in Android. There are many applications available in Play Store which will allow you to run the Python within your Android device. So as I was telling in the very start of it, we have an object-oriented feature which allows us to represent entities in the form of objects. And there is also this part of procedure-oriented which allows us to break the code into individual small snippets rather than defining the whole thing into the object. So Python allows both of these features. We can just benefit from both of these features. So rather than just a one, some languages, why the benefit of two is, in some languages there is only object oriented, in some languages you only have a procedure oriented. So that becomes a difficulty that you cannot use the other one. That's why having a both of mix gives a lot of flexibility. Okay, so there is an extensibility. So in this, we develop the code in Python, but that Python code, if we want to interact with some different language programs, like if there is a C program, there is a C++ program, there is a Java program or a .NET program, and you want to talk with them. You have a Python program, they have a different language program, and you want to see, okay, how can I connect from a Python program to the C++ program. Python has created some extensions. For example, they have a Cython, C-Y-T-H-O-N, for Cython, which allows you to create a code inside the Python with a C language, and this code can then interact with the actual Python code. That's the beauty, because C is a very flexible language, and C is a bit difficult to write, but it has a very good uses. It is very fast, it is very good. So if you can write some part of the code in C, but other part in the Python, you will be still able to interact with them. Whereas even the Java has a Jython, J-Y-T-H-O-N, where you can write the Java code inside the Python and run it, and your Python code will be able to interact with it. So as you see, Python has like a very wide variety of features. It provides us a whole mix of like a single box for all the different activities. So let's see some applications of it. Has anyone heard about web scraping? Anyone knows about web scraping? Yeah, you can say like yes or no if you know about it. So I see one question is platform independent. Yes, it is actually platform independent, means we can run a Python code which you have written in Windows. That same code you can run on the Linux, or you can run that same code in Mac OS. So it is like completely independent of the platform that you are using. So all these operating systems, we call it as a platform. So Python runs completely independent of the operating system that we have. So web scraping is basically one of the features which allows us to extract data from the web. So if you have a stock market ticker data, or you have a Twitter based data, or you have a Facebook thing, or you want to scrape something from the Google's web page. So if you want to fetch that data, we have a web scraping. So web scraping allows us to fetch the HTML code from any website. So Python has one library called as Beautiful Soup, which allows us to scrape the websites. Just to be cautious, you should not be scraping any website. There are many regulations around scraping the websites, but Python has this feature which allows us to scrape data from the websites, and you can use it for any kind of an analysis. People do scrape the cricket data, the football data, the tennis data, which is like live updating on the site. They keep on scraping it to develop some application of their own. Web development has recently been, not recently, it has been there from a long time, but now also like it's booming a lot with Python as a backend. So there is a framework called as Django. So Django has a web development features for everyone to use. So you can develop web applications using the Django library, so which is a part of Python. Python has this Django library internally. Testing, for Selenium based testing or for unit testing, for all the different kinds of testing, Python has the library. So we can do all the kinds of testing again with the Python. Data analysis is something that we are going to look. So there are various libraries like Pandas, NumPy, Matplotlib. So all these libraries we use for analyzing the data. So this gives us a lot of flexibility. These are not just the features. We have the machine learning based libraries, we have a cryptography based libraries, we have like there are various forms of libraries which are there for date handling, for JSON handling. So for any kind of a database you have, you can connect with those databases. So all those features are present. So data lifecycle. Now as we go towards the data analytics, let's understand what do we have for the data lifecycle. In real world, we have a data coming from various different sources. We have a data from databases, we have a data from websites, data from the different log files, JSON files. There are various forms of data which is available, and we want to analyze all that data. To analyze it, we have a data warehouse which tries to gather all this data and transforms this data to a form which will be readable by us, because analyzing these various forms has been difficult. So we try to transform all of them to a single form, and then once we have all of them into a single form, it is much easier for us to do this data analysis. So this data, the major challenge that we have when we are trying to deal with the data is collection of this data and transforming this data. The cleaning of the data, the processing of this data is the biggest time consuming task, because there is no single way to try to analyze this, convert this data. Every data requires a different way to transform it. So if we have a textual data, we have a different ways to transform it. If we have a video based data, we have a different ways to transform it. If there is an image based data, we have again a different ways to transform it. So all these parts happens in data warehousing is we try to aggregate all of this data, get it to a same form. Once it is available in the same form, the majority of the target for all of this data is a table based outcome. At the end, we are expecting the data to be in the table form, where it will be rows and columns. Everything will be in the form of rows and columns. Once that is there, it will be like an Excel kind of a sheet that we can use for doing any analysis. We can come up with the visualizations, we can come up with the statistics, we can go with the predictive modeling. So that is the overall life cycle that we have, and we will still try to break down all this various data parts. Okay, so now let's come to like, why do we need this data science? This term data science, what does it actually mean? As everyone is right now booming with the data science, every company is going toward it. What is actually happening with this? The reason is, there are like, traditionally there have been certain type of data which is like, the data was very structured in nature, everything was in the tabular form. There were data warehouses which used to like aggregate this data and store it, which were then sent to the business intelligence applications, which there were like different business intelligence applications which used to analyze, get some statistics out of this data, and then from that statistics we used to get some reports and like what happened, what was the reason, like what happened, all the things you will be able to visualize. But now industry is going towards something different. People are not just interested with the historic data, but people also are interested to see what all we can do for the future. And the biggest challenge is we have a data which is very unstructured in nature. The structure of the data is not very simple for us to use it directly for any kind of analysis. So the first thing comes is, how do we structure this unstructured, semi-structured or a structured data to a one form? Hadoop, Spark and big database architecture helps us to transform them. So all these big database architectures will allow us to like convert this unstructured form to a form which we can use for analysis. And then data science algorithms allows us to find some patterns within the data. If we have, let's say, customer purchase data, so in that customer purchase data, if you think of any big enterprise like Big Bazaar and the other things, they will have a huge amount of data per customer. So you can imagine in a day itself they will have so many transactions happening. Analyzing the data is very difficult. So that's where like Hadoop and the Spark like architectures, the big data architectures will try to store that data and then we can use the data science based algorithm to identify which customer are interested in buying what thing. If they buy one thing, how can they buy the next thing? So how do we target them with the new products? So all that kind of a discovery that we do with this data science algorithms from the data. So this discovery is then what we are interested in, how do we use this data for future. Unlike the historic way of analyzing the data where we were only interested in what actually happened in the past and how do we, if there are mistakes, how do we take it forward, if there are good things, how do we take it forward. But now with the data science we have how do we use this historic data to make a prediction for the future. We try to learn some patterns from it and then use those patterns for a future analysis. In the data science, the two parts are separated, where we have a data analysis and the data pre-processing, and then there is a model part, like the learning part. The real data can come from various forms. It can be any form. So as we discussed, there could be text, there could be web pages, there could be images, there could be videos, there could be tables, there could be JSONs, XMLs, log files. There are various different forms which will be available to us. We want to transform them to a desired format and then a cleaning of the data. Now what do we mean by cleaning? Why do we require a cleaning of the data? So cleaning is important because the data many times has a noise. This noise, it is important for us to remove this noise for a better analysis. There will be many times a blank value. The text that you get will have some unwanted data like some noise, or it will be blank in many places. Either you have to replace those blanks or you have to remove those rows because those will not be useful for analysis. If you have a date of birth as an input, analyzing a date of birth, we as the humans, when we look at the date of birth, we may be able to make some interpretation out of it. But for a machine, identifying the date of birth, any patterns from it is slightly difficult. So either we try to split the date into the day, month and year into 3 different columns, or we try to create an age out of that column. So that kind of pre-processing something which goes into this. One more example would be like if you have a full name of a customer. So full name would be the first name and the last name and the middle name. But now this whole string may not be very useful directly. But if you try to split it into the first name and the last name into 2 separate columns, the first name may be very dynamic, but the last name may try to give you who's into the same family, who's into the same thing. So that different patterns can come up out of it. The other example would be if you are trying to analyze a room, and in that room you have like a height and width of the room, and area is something that you can create out of that data. So there are various transformations, cleaning that can happen. Cleaning, one more thing is, if you have a data which like you collected the data in a survey. In survey, many people will not fill some of the information. They will keep it blank. They will not fill all the information. Some information they may skip. But now when it comes to your analysis, you need to make a decision whether to keep that data or remove it, because many people have not filled it. If many people have filled it and some have not filled it, what you need to do with that. So all those different things happens here. Once we have a data in a complete clean format, then we go for the model. These models are nothing but a ways or a mechanisms or some algorithms which tries to learn some patterns from the data. So they try to go into the data, learn some interesting patterns which will be there. So these patterns are very useful for us to make a future decisions. So we try to analyze the trends and we make some better decisions for the future. And in this, in reality, in real world, the step which is of the cleaning and the transformation takes close to 70 to 80% of the time. This is a majority of the task where once you have the clean. See, in the model, in the predictive part, whatever you give, if you feed it a chunk, the output will also be a chunk. If you feed it a right data, it will also give you some right knowledge out of it. But if you feed it wrong data, it will not be able to come up with the right answers. That is why you need to spend a good amount of time in the cleaning so that your analysis will also be of good value. This data science has been there from a very long time. This has been going through different names. Just people have been like using a different names for it. So it has been a predictive analytics, it has been a statistical analysis, predictive analytics, and now there is a machine learning, data science, artificial intelligence. All these are different terminologies that people keep on giving to these systems. So there is a deep learning. All these are different ways, but we're talking about a similar thing as how we analyze the data. The slight variations are there in between them, but all of them are talking about a similar thing. Now data science is about the whole science where we are trying to go from collection of the data till the prediction, implementation, and the evaluation of the data. So data science is about the whole thing. When we talk about machine learning could be only about learning the patterns from the data. But data science is the concept which goes on from the start of the project till the end of it. So we start with the raw data, we try to convert this to a structured data repository, and this structured data then goes on to the warehouse. Warehouse tries to do some aggregations and try to compare it with the other various data. So warehouse allows us that flexibility. The traditional BI will try to just learn the historic patterns which are there in the data, and then it will give us a predetermined report, which is just what has been happened in the past. Yesterday there was an increase in the sale, day before that there was a decrease in the sale. So it can only give you the information that something has happened in the past, and it will show you those in the form of graphs. So as I was talking in the previous slides, the role of the data scientist is majorly like the preparation, the analysis, strategy, modeling, and the decision making and all. But preparation and cleaning is a stage which takes a lot of time. The majority of the chunk goes into this part here. So revolution in this case is like now the data is changing a lot. So we have a lot of new types of data. There is a Facebook, there is a video data, there is a image data, there is a text data, logs data, data in the form of JSON, data in the form of XML. Just various forms of data is available. So traditional BI cannot solve this data. It is very difficult for traditional data to look at the videos and the images and to come up with the solutions. So what is like difference between this BI and the data science that we have? So as I was telling, BI only looks for the backward data, which is the historic, whereas data science tries to look how can we go for the future. In this, as we know, it only tries to look at the structured, semi-structured data, which is mostly in the numerical form. But data science has to deal with all the various types of data. In this, the work is basically to try to come up with some reports, and a predict is just based on the history. Can we do some small predictions and do some prescription and the optimization? Data science tries to do a predict, exploration of the data, investigate any issues, we try to visualize the data. So it is like a broad field which is there. BI requires a big investment. There are very big tools which are there in the market for handling this data. You need a space, you need a good number of tools to analyze this, whereas data science has a many open source applications, requires some little amount, but the results may not be that good. The results sometimes, like as we are dealing with the huge data, and this data may have a noise, and the problem statement which we may try to define may be more complex. So results may not be 100%. We can never achieve 100% results with data science because the data which we deal always has some noise. So characteristics, we can repeat the analysis for different data, and in this also we can do the same thing. So business intelligence, we try to do mean, median, mode kind of statistics to understand what is there in the data. Whereas with data science, in data science we have the statistical component also, but on top of the statistical component, we have various tools which helps us to analyze and work with the data. Okay, so era of data science. Guys, I'll come to the Q&A part. So please keep on posting your questions. So we will not be running out of the time. So I'll cover the content and we'll be able to answer your question. So please keep on posting your questions if you have any. So now with the era of data science, we have various tools and frameworks. And for many new people, it becomes difficult as, okay, what should I start? How should I start? Which is important? Which is not important? It all depends on what you are interested in. If you are interested in big data, there is a Hadoop. If you are interested in only Python, there is a different thing. Azure is there, which is a cloud-based operating, the cloud-based structure, which has a lot of different services. R is a majorly a statistical tool, but nowadays it has expanded a lot to include all the machine learning based thing. Many of the non-technical people likes to go with R. Many of the technical people likes to go with the Python. There is a Spark, which is for Spark and Hadoop falls into the similar family, where both of them are trying to handle a big data and come up with the analysis. R and Python falls into the similar bucket, whereas Azure and AWS, Google Cloud, all of those are cloud-based services. If we try to integrate all of these new tools which are there, which allows us to make the analysis faster, the cleaning of the data faster, the processing of the data faster, the data preparation and cleaning stage slightly reduces here. It gets down so that people will be now able to focus more on the modeling, the decision making, the strategizing. So people can now spend more time on this if you're using all those tools which are available. But other than those tools, we need to spend a lot of time on data analyzing and cleaning. Now, this is an important question that many of you would be interested to know as, okay, what happens if we learn? What is going to be there at the end of it? The report says there has been a big growth that is happening in terms of the usage of the data science. Many people are searching, the jobs which are there in the Indeed are increasing. There is a time when this was like high, suddenly there was a small drop, but now again there is a good increase which is happening in this overall search part. It's like slightly old one, but now like it has gone very high and there is a lot of changes which have happened in terms of the searches. So even if you see Python is in the top here. So if we compare the Hadoop and the cloud systems, Python is still at the top. Data science is like a general thing, so the major number of things include the data science, but there is a Python, there is a data science. Everyone is just trying to go above. The people in interest for data science is just going high. This is like just a different version of the same, but this is a Google trends now, like how people are searching these terms. Over the time, many of the people are now interested. Everyone is trying to get into it. All the companies that I have interacted, everyone wants to go into data science. They want to see like how we can use it to transform our businesses. So that is the goal for many of the companies. So the search has tremendously increased now over the time. So this is the again important part. So what all do we require so that we become a data scientist? So what all are the important things which are there for a data scientist? As I said, data science basically includes from the start of the life cycle where we start collecting the data, we merge this data in a data warehouse, we clean this data, we transform this data, then those transformed data goes on to the machine learning algorithm. Machine learning algorithm learns the patterns from it, and then we use that patterns to make a prediction for the future events. For this whole life cycle, we have a different components being there, and all those components are important for a data scientist. We need to know the statistics and probability. Now, you may ask like, why statistics and probability? Statistics and probability is all about data. Data science is again all about data, and statistics and probability all talks about what is there in the data. So that's why statistics and probability is very important. There is the inferential statistics, there is the descriptive statistics which are there. And after that, programming languages like Python and R are important. So programming languages will give us a tool to implement this. Knowing just the statistics and probability and machine learning will not be enough. We need a tool which will help us to implement it. That is where the programming language of Python and R comes into play. Then there is the data mining skills, as how do we mine the data, how do we transform it, how do we analyze it to understand it. Then we have a machine learning. In machine learning we have various algorithms, linear regression, logistic regression, TSVM, random forest. There are various different types of algorithms which we use to analyze the patterns from the data. So this learning is very important. And big data. The data that you have to access will be stored into the big data architectures. Now to access the data, you need to know basics of the big data technologies. So at least at the start you need to know, okay, how should I access the data, how should I fetch this data. So to do that, you need to know the big data architectures. And then a visualization. As we are dealing with a very huge amount of data, going through that data is a bit difficult. If you want to find out, is there any problem in the data? So problem can be quickly found out just by looking at some simple visualizations. You get to know whether this data is right, whether this data is wrong, or whether there is something abnormal happening in the data. You get to know all that with the data visualization steps. Okay, so now coming to what MICS can provide in this case here. So the certification program has a different components for you to go through. So fundamentals, like what is machine learning, the basics of it, the data science, the programming, the Python and R part, the statistical understanding, visualizations, the big data architecture, how to analyze the data, how to transform the data, and how do we go for the data driven problem solving. That's a very important step. Everything roams around the data. So you need to know, okay, how do I create my problem solving around the data. So the Python curriculum includes all these components. So just to show you for the web, let me just show you on the website the courses which are there that you can have a look at. Can just say yes if you are able to see the screen in a browser. Just say yes if you can see a screen in a browser. Okay, great. Thank you very much. So this screen now shows the different courses which are there in the MICS. So you will see that there is a Python training for data science. This is a Python course. This is a Python with the data science course. This is with the SAS. SAS is a one more different tool which many of the companies uses, which is not open source, but many companies use it for the stability of it. And data science with R. So as I was saying, R and Python are just the two different languages which we have in the industry for the data science. So all these courses will be able to take you through all the things which we discussed, which are required for you to go through the data science life cycle. Now let me come back to the PowerPoint which we have. So you have like a lifetime access to the content which is there. So there are live instructor led interactive sessions where you can like keep on asking the questions and get the live recommendations and answers from the experts. Every class gets recorded. You will have access to those recordings post the class. If some people misses the class, they'll still be able to hear it, and even after some months or after you want to just revise the concept, you can still go through and listen to the recordings. There are various projects. Now this is a very important part because many companies requires not just the learning, but what is an important thing that you have done in the implementation. How have you implemented? What have you implemented? What are your learnings? So many companies would be interested as what you have done. So with MICS, we have a lot of different projects which will help you to learn the way these things actually work and how in real world we are able to apply these things. And yeah, there are like different problems. So just one example, as you are working as an analyst and you have to create a model that can actually predict which employees are going to leave the company. So you know that when a person's age is this and the person is working in this department and the person is working as a role, so you know different perspective of the employee, and you also know whether that employee actually left in the past or not. You get all this data, and using this data you have to create a model which can help you to make a prediction for a further employee as a future employee. So you will take them, once the model learns the patterns, you will be able to apply it on a new people and see whether this person is going to actually leave the company or not. Don't worry, your company may not have this yet and you will not be known with this. Okay, but yeah, this is like the overall life cycle that we have, where once the cleaning part is done, once the processing part is done, we get to the training. Training is about how do we learn the patterns from this data. So these patterns, we pass in this training data to the algorithm. Algorithm learns some patterns. We call it a model. So model is nothing but some learnings which are extracted from the data. The patterns which are extracted from the data, we call it as a model. Once we know the patterns, and the moment we get a new data, the testing data, we try to apply this model and see the outcome. And using that outcome, we see how good the model is actually learning the content. This is like in the school, when teacher is trying to train a kid, they will come up with the questions. They will ask the students, okay, the questions, and they will check the homework and everything. They see, okay, student is working good. But now, whether to know actually that he has actually learned the whole thing. So we do take a test yearly, bi-yearly, like that. So those tests help us to actually see how good the learning has been there for that kid, how good he has learned. Similarly, in the modeling also, we try to train it and then we try to test it at how good it has actually learned and whether it can work with the new data or not. So that is the whole picture of it, guys. I hope you enjoyed it. But yeah, now let's go toward the Q&A. So please post on any questions that you have. Okay, so one question that I see is, need to clean all type of data or some format of data. So as I was telling, the goal is to transform every data to a row column format. If the data is not in a row column format, like the image data, the video data, yes, even image and the videos data can be converted to the form of the row column. There are ways to do that, like JSON data, XML data. If you know about those, all those are like different forms of data. And when we have these various forms, we want a way by which we can convert them to a form in the table form. So everything at the end should be in the table row column format. I hope that clears the question. Any other questions?
Yes, can you hear me?
Yes, I can hear now.
Okay, so question part is done. So can we conclude the sessions, or you want to go ahead with the more questions and answers?
I guess we don't have any questions further now.
Okay, so no worries. Thank you for that. So Rishikesh, thank you so much for your valuable time, and this session has been really interesting as from my side, and as well as I think the participants also really like the sessions. So thank you so much again, and all the participants who have given this valuable time for the sessions. And after the sessions, we'll share you the feedback session so that you can just provide your insights, so that we should understand how this training and the session went out, so that will be helpful for us for the future, so that we can make a changes on that. And apart from that, yes, we'll also provide you the recorded links of this session, so that you can go with this session again for these queries and doubt. And even though you can share it with your colleagues, your friend in the social media, so that they also know about this MICS, how it works out, right? And even though in behalf of Magnet Infotech, again I will say thank you. And you do have our website, that's mics.magnet.in. For the further requirement of courses and this training and all, you can revert back to us. You have this MICS website as well as number as well, and we'll be there to help you out with all this provided trainings apart from this Python, machine learning, everything we do have. So fine, Rishikesh, thank you so much. And this is Prashant here again. I'm signing out. Let's catch up after Monday if we get the feedback from the participant and all.
Thank you everyone. Thank you for Saturday time. Have a good day. Bye.
You too, Rishikesh. Bye-bye.